Hello, welcome to Technoveda Solutions.
In this video, we will discuss about function overloading. We know that function overloading comes under polymorphism. Okay, so we are going to discuss how exactly a function loading works and how do we implement that. So let's begin. So in the first session only, we have discussed that the function overloading comes under the polymorphism feature, and that we have compile time and runtime under polymorphism, and function loading is under compile time polymorphism. So we'll see how do we do that. So function overloading is a feature in which the functions will have the same name with different parameters. Now what does that mean? We can have a multiple function definition having a same name, but the arguments what we pass to those functions should be different. Now how can we make that different? There are three ways. First is making the data type of the parameters separate or different. For example, one function takes an integer value and another function having the same name takes a float value. Then those two functions are said to be overloaded. Now they are called based on what argument we pass. If we pass a float argument, that particular function is called, and if we pass an integer argument, that particular function is called. Similarly, another way of passing the arguments is making the number of parameters different. Say one function takes only one parameter and another function takes two parameters, but both the functions are having a same name. Now depending on how many arguments I pass while calling the function, that will decide which function to be invoked. If I pass only one argument, then that particular function is called, and if we pass two arguments, then that respective function will be called. Like that, we can differentiate the functions based on number of parameters. And the third way of doing that is order of parameters. In case of order of parameters, we change the order even though data types are same. For example, we have one function taking an integer and float as an argument, and we can have another function with the same name taking float and integer as an argument. Now if we observe in the example what I just explained, both the functions are having the same number of parameters and data type is also same, but the order of data type is different. One function is taking integer first and then the float as a second argument, whereas another function takes float as a first argument and integer as the second argument. Like that, we can change the order of arguments and overload the functions. To discuss all these things with example, we'll go to directly coding. We'll see how exactly coding works, how it is implemented, and we will execute and check the output. Okay, coming to the code. So I'm using a VS Code compiler. So we can use any compiler, no issues with that. So the programming will be same in any compiler. So we are including a header files, and then we are defining a namespace standard. I will discuss about this namespace, why it is used, and can we have a multiple namespaces, how it can be used. That all we'll discuss in the later sessions. Just now we just know that we have to use a namespace for the operation or the proper execution of the code. Then I'm defining one class. In that class, if we see here right now, I have not declared any access specifier for the variables. So both int and float is just kept, and by default they will be working as a private. If we don't give any specifier, then it will be taken by default as a private. And here I have defined a public scope, and all functions I have declared under the public scope. Now in the public scope, the first function is get values. So it will be reading the values for v1, v2, f1 and f2. I expect to take the inputs from the user, and once we get the user, then we are doing the addition operation for the various combinations. So I typed the entire code to avoid the typing time in the discussion. So in the int first function int add, we have a two integer as an arguments, and we are returning the addition of that. So we are returning the integer. We are passing both the integer and we are returning the integer value. Then in the next function, if we see, we are passing both the float value and returning the float value as a return value. So now these two functions are having the same name but different arguments. That is one type of overloading. Then we have another add function here, two variables which are having a different data type. One is integer, one is a float. And when we have a float and integer, the return data type should be float, so that we will have the float return. Otherwise, what we get is the truncated output. Then we have one more function add. Here we are passing only one variable. So here we can see integer, it is having a two variables. Here it is having only one parameter. So this is another way of overloading, where we can differentiate the functions based on the number of parameters what we pass to the functions. Either we are passing a one argument or we are passing a two arguments. Even the argument data type is same, the number of arguments are different. Then based on that, the functions will be identified. Then another type of overloading what we just discussed is the order of the data type or the parameters. Now here is one function which is having the integer and float as an arguments, and here is another another function with the same name having float and integer as a arguments. Now we can see the return data type is same for both the function, name of the function is same, the arguments are both integer float, float integer, arguments data type is also same, but their order is different. In this function, integer is taken as the first argument, float is taken as the second argument, whereas in this function, float is the first argument, integer is the next argument. So this is another way of overloading. So these are the three different ways how we overload. One is different data type, another one is different number of arguments, another one is different order of arguments or the data type. Now once we do that, then I'm closing the class and terminating the class with the semicolon. Then we are coming to main function. Here I'm creating a object. This is called instantiation of the class or creating object instant of the class. We know that object is referred as a instant of the class, and creating the object is instantiation of the class. Now this is a class name what we are given, and this is a object name. So whenever I want to access any of these functions or these variables, then I will be using a dot operator to access the members of the class. Now get value is a member function, so I'm accessing that using a dot operator. So object dot function member or a member function. So we are calling that function. So first it will take all the inputs whatever we need. So two integer values and two float values we are taking as a input. Then I'm declaring two variables for the results storage, result1 and result2. One is an integer and one is a float, because we have both the type of operations to be performed. Then here result1, we are taking first, we are calling two object variables using the dot operator. Again, both are integers here, v1 v2 both are integers. Now we can see here all these are underlined with the red, indicating that inaccessible. We can see the message there, the member is inaccessible. That means what? We are not able to access that, or we are not allowed to access that. That is because we have made these two private. So what I will do is I will just remove this public from here and I will paste it here. Now if I scroll down, there shouldn't be any error. Now you can see that there is no underline. Now we are able to access them because now I have declared them under public itself. Now member variables are also public, member functions are also public. So all the things I can access from the main function. Okay. Now here First I will be calling add function with the two integers and then add with a single value. When I send a single value, I'm just incrementing that value by 1. And then we call a function add with the one float, both the float values, then one integer one float, and one float one integer. So now we will see how to see the output. Just before that, I want you to know that the cin and cout, these what we have used here everywhere, cin and cout, these are the objects of the class iStream and oStream. Remember, they are not a function, they are the objects. Cout belongs to oStream, cin belongs to iStream. So this iOStream is derived class from iStream and oStream. So both the functionalities will be there in the iOStream. So instead of including two separate header file like iStream and oStream, we can include only one header file, iOStream. Okay, then we can use both the objects. So now we are using this cin and cout without knowing their implementation. That means we are abstractly using them. That is the another feature, abstraction, what we are discussing about. Cin and cout, without knowing the implementation, we are using that, interfacing that. So abstraction is where implementation and interfaces are separated. So now this is a abstraction concept. Similarly, we are putting all these variables and function within one particular section called class, that is encapsulation. Okay, now let's run the code. So it takes some time for the execution, depends on the system. So now first we have to enter two integer value. Let me enter 5 and 10. That's for the two float values. So I will enter 2.5 and 5.5 and then press enter. So let's cross verify the answer. So the first function what we called is two integers addition. So 5 and 10 gives us a 15 as a return. Then we have one function, one integer is being passed to the function add. So the value passed is 5, return value is 6. That is added 1 to the passed value. Then we have a next call, both the float values 2.5 and 5.5. So it is returning 8. That is 2.5 plus 5.5. In the next we are passing one integer, one float. Now here we can see the integer is 5 and the float is 2.5. Both v1 and f1 we are passing. So v1 is 5, f1 is 2.5. Return value is 7.5. Now observe here in the next function we have f1 and v2. So f1 is 2.5 and v2 is 10. So that will return 13.5. That's because we are adding one extra here, x plus y plus 1. That's why it is giving us 13.5. Now I will tell you one more thing. If we make this as an integer, suppose I'm passing a float and integer, but I'm returning an integer. Okay, now what happens? Now let's execute that. Now I'll give the same values, 2.5 and 5.5. Now you can see it has returned the integer. Now that means previously it has entered 30.5, it has given this 0.5 is truncated now. So that care should be taken because it will not give any error or a warning. So it will just truncate the value, typecast it and return that. Okay, so that is something similar to implicit typecasting. So we should be careful whenever we are using different data types, and if we are returning the value related to the operation to those data types, then whichever we have a highest data type, that should be given as a return data type. That one care should be taken by the programmer. Okay, so this is the code. So I think we understood three concepts today: function overloading, abstraction and encapsulation. Okay, that's it for this video. If you like video, click on the like button, subscribe the channel and share the video with your friends. And if you have any doubt, please don't forget to add the comment. I will reply to the comments as soon as possible. Okay, thank you. Have a good day.